students, I am Nilanjana Sanyal. Welcome you all to my channel NS Online Math Classes. Our today's topic is evaluating a logarithmic expression without calculator. If you are allowed to use a calculator, it's fine. Suppose you are given a logarithmic expression as find the value of log 100 to the base 10. It is a very easy question. So, you may not be needing the calculator, but you may be needing a calculator if you are new to this chapter, logarithms. So, log 100 to the base 10, if you use the calculator, first of all, it will be depending on which calculator you are using. Either you have to press the log button first and then you have to type in the 100, or else you have to first input the 100 and then press the log button. Okay, but anyway, you will be getting the answer as 2. But what if you are not allowed to use a calculator? Like for IBDP people, they have a paper where the calculator is not allowed. Even for IGCSE 0607 paper code, you are having a paper, or rather they are having a paper which doesn't allow the calculator. So, and for them there is a chapter on logarithms. Even for IBDP, they are having the chapter on logarithms. How to find the value of a logarithmic expression without the help of the calculator. This is the topic of our today's session. So without any further delay, let us start with our session. First of all, let us look at the given rules. Rule number 1 says form an equation by equating the logarithmic expression to p. Like I have taken the logarithmic expression as log 100 to the base 10. I'll be equating that to p. So log 100 to the base 10 equal to p. Rule number 2 says convert to an exponential equation. Now we know how to convert a logarithmic expression to an exponential equation, or logarithmic equation to an exponential equation. And then rule number 3 says make the bases of both the sides of the equal to sign the same and equate the powers. Okay, so these are the rules. If you are getting confused by reading the rules, don't have to worry, we will be taking up specific examples. So let us look at the given questions. Find the values of the following logarithmic expressions. Question number 1. Log 27 to the base 3. What do we do first? We form an equation. It is log 27 to the base 3 equal to p. I have taken this letter p because I wanted to stick to that BAP and BPA rule. Okay. And since it is a logarithmic equation, it is following the BAP rule. It is B is the base, A is the argument, and P is the product. That is why I have taken this letter P. And when we have to convert to an exponential equation, this is rule number 2. So the base will remain the base, the product becomes the power, and the argument becomes the answer. So it will be 3 raised to the power of P equal to 27. This is the exponential form, that is the BPA rule. B is the base, then power is P, and A is the answer. Okay. And next what we do? Make the bases of both the sides the same and equate the powers. So we have to write the right hand side as some power of 3. And we know 27 is 3 raised to the power of 3. So we write that. 3 to the power of p is equal to 3 to the power of 3. So now the bases are the same on both the sides. So we can equate the powers. P is equal to 3. Therefore, what was p? P was log 27 to the base 3. So log 27 to the base 3 equal to 3. Okay. So we have found the value of this logarithmic expression log 27 to the base 3, and it is equal to 3. Coming to question number 2. Log of 1 to the base 4. Again, we will be taking this to be equal to p. And then we will be converting this to an exponential equation. It becomes the base raised to the product, which is now the power, which will be equal to the argument or answer. So it is 4 raised to the power of p is equal to 1. And then how to write 1 as some power of 4? Because we have to make the base the same on both the sides of the equal to sign. We have to write 1 as some power of 4. So we know anything raised to the power of 0 is 1. So we will be using that law of indices. So it is 4 raised to the power of p is equal to 4 raised to the power of 0. So now the bases are the same, hence we can equate the powers p equal to 0. And what is p? P is log of 1 to the base 4. So log of 1 to the base 4 is equal to 0. Coming to question number 3. Log of 0.5 to the base 2. Again we will be equating this to p and converting this to an exponential equation. It becomes 2 to the power of p equal to 0.5. And now you do not know how to express this 0.5 as some power of p. So since you do not know, don't stop and don't think that you have made some mistake. You have not made any mistake. Just write this 0.5 in a fraction form. It is 5 over 10, which is equal to half. Now you see you are having this 2. Instead of 5, now you are having this 2. And half can be written as 2 to the power of negative 1. So it is 2 to the power of p is equal to 2 to the power of negative 1. Therefore, p is equal to negative 1, or log of 0.5 to the base 2 is equal to negative 1. Okay. Coming to question number 4. Log of square root of 125 to the base 5. This should be equal to p, and then we will be converting this to an exponential equation. It becomes 5 raised to the power of p is equal to square root of 125. Okay. And we have to express this right hand side as some power of 5. We know 125 is 5 to the power of 3. So, and there is the square root. So 5 to the power of p is equal to square root of 5 to the power of 3. And when this third form is changed to indices form, what we have? This square root will be, the equivalent power will be half. So it is 5 raised to the power of 3 times half, or 5 raised to the power of 3 over 2. If you are having any difficulty in this conversion, I would definitely be asking you to watch my videos. Most probably they are shorts, math shorts on indices or exponents. Okay. So it is 5 raised to the power of p is equal to 5 raised to the power of 3 over 2. Now the bases are the same, so we can equate the powers, and p is equal to 3 over 2. And what is p? It is log square root of 125 to the base 5. This should be equal to 3 over 2, or you can write this as 1.5 as well. Okay. So students, this brings us to the end of this session. Please like, share and subscribe if you find this video helpful. Thank you for watching this video till the end. We meet again very soon. Till then, bye.